Hello guys, welcome to my YouTube channel Pharma Learning with Deepika. For the previous videos on flow of fluid, the link is in the description. So today we will study Pitot Tube. Pitot Tube is basically used to measure the flow of fluid. It is basically a hydrodynamic method. So first of all, what is Pitot Tube? Pitot Tube is basically called as the insertion meter also, because you can insert wherever you want to measure the pressure difference. So let's talk about the principle. Pitot Tube consists of a sensing element with a small constriction compared to the size of the flow channel. So when the sensing element is inserted at the center of the stream, the velocity of the flow is increased. So this results in the decrease in the pressure head, and a tube at right angles to the flow measures the pressure head only. So the tube that pointed upstream measures the pressure head and the velocity head. So the difference in the above reading indicate the velocity head. So according to the Bernoulli's theorem, you know very well that when the velocity increases, pressure head decreases. So this is the equation by which you will calculate the flow of fluid with the help of Pitot Tube. That is del HP equals to U square upon 2G. So del HP is the difference in the pressure head from the manometer, and U square is the velocity of the flow at the point of insertion. This is the diagram of Pitot Tube. So here it is upstream end, here it is the downstream end, and this is the limb which is used to measure the pressure and velocity head, and this limb is used to measure the pressure head. So now let's talk about the construction. So Pitot Tube is also known as the insertion meter. So the size of the sensing element is small compared to the size of the flow channel. The point of the measurement may be at the center of the channel. So one tube is perpendicular to the flow direction, and the other tube is connected parallel to the direction of the, here you can see this one is perpendicular and other is parallel to the flow of fluid. So the two tubes are connected to the leg of the manometer or with the help of a suitable device. Now let's talk about the working. Two tubes are inserted into the pipe in the pipe, as you can see in the diagram. So Pitot Tube is used to measure the velocity head of the flow. In this tube, the velocity of the fluid is increased at the narrow construction. So this results in the decrease in the pressure. According to the Bernoulli's theorem, when the velocity increases, pressure got decreases. So the tube at right angle to the flow measure the pressure head only. The tube at point stream measure the pressure head and the velocity head. So the difference in the above reading indicates the velocity head. So therefore the reading R of the manometer measure the velocity head. This reading R gives you the velocity head. So as seen in the Bernoulli's equation, velocity head of the fluid, that is del HP, may be obtained from the following equation. We have already talked about the equation, that is U square equals to 2G del HP. Here you can calculate the velocity head. This is the velocity head. So what are the advantages? So what are the advantages of Pitot Tube? Pitot Tube measures the velocity at any point. So you just need to insert it wherever you want to measure the flow of fluid. So you can insert the Pitot Tube. So this is the advantages. Now disadvantages, like the Pitot Tube themselves cause more disturbance. So eddies within the pressure tube disturb the reading. And the second advantage is that do not give average velocity directly. For gases the reading is extremely small, so the gases working on the low pressure, some from the multiplying gauzes must be used when you want to measure the pressure of gases. So what is the difference between the Venturi, Orifice and Pitot tube? So Orifice and Venturi meter measure the average velocity whole stream of the fluid, but Pitot tube measure the relative fluid velocity at single point only. More pressure drop we will get, and in Pitot tube will get less pressure drop. Now let's talk about the rotameter. Rotameter is also called as a variable head meter because you can measure the variable difference. So it measures the area of the flow so as to produce a constant head differential. Therefore rotameter is known as the it is also known as the variable area meter. Now come to the principle. So rotameter is consist of a vertical tapered and transparent tube. Here you can see it is a vertical tapered transparent tube in which plumette is placed. This is a plumette. This yellow color thing is a plumette. During the fluid flow through the tube, the plumette rises and falls because of the variation in the flow. This plumette go up and down due to the variation in the flow. As a result, the area of the annular space between the plumette and the tube varies. The head loss across the annuals is equal to the weight of the plumette. So the upper edge of the plumette is used as an index to notate the reading of the tapered tube. This value indicates the flow of fluid. Now talk about the construction of the rotameter. So rotameter consists of a vertical tapered tube which is mounted in a with a narrow end. So the tube is usually made of a glass on which the linear scale, here you can see the linear scale is hinged. A solid plumette is placed in the tube. The diameter of the plumette is smaller than the narrowest part of the tube. Rotameters are available with electric and electronic transmitters for reading. Floats of different densities are available so that 200 float range of the flow can be measured accurately. Floats may be made of the lead, aluminium, glass and the plastic. So now come on the working of the rotameter. As the flow is upward through a tapered tube, the flow of fluid varies. So the plumette which is surrounded by the fluid rise and the falls depending on the rate of flow. So greater the flow, the higher the plumette rises in the tube. In rotameter, the pressure drop is constant or nearly constant. So during the fluid flow, the area of the annular space between the plumette and the tube varies. So therefore the head loss across the annual is equal to the weight of the plumette. So the flow may be read using the upper edge of the plumette as an index. The area is proportional, so the area is properly calibrated to the flow rate. So the reading may be transmitted from recording, integrating and controlling. So what are the uses of rotameter? So basically rotameter are extensively used in chemical industry such as bulk drug. In the fermenters, the supply of the air is controlled through rotameter only. So rotameter are satisfactory both for the gases and for the liquid at high and low pressure. So what are the advantages of rotameter? Basically operator has a direct visual index of flow reading. It is satisfactory for manual control of processes for experimental work. It does not require the condition for straight pipes should run before and after the meter. Now let's talk about the direct displacement meter. So direct displacement meter is used for measuring the domestic water supplies. This has the advantages that the total volume of the liquid that has passed can also be read directly. So basically direct displacement meter is used for the domestic water supply only. The principle of direct displacement meter is used to measure the flow of fluid in the small lines. In this meter, a stream of the water enters the meter and strikes the moving member. So the rate of rotation of the moving member is proportional to the velocity of the water passing through the meter. So the displacement of the moving meter is transmitted through a train or a gear to the counting dial, which is present in the top of the member. So what is the advantages of direct displacement meter? The displacement meter have advantages over Venturi and Orifice meter in the sense that the reading present the total volume of the fluid that has passed. This volume divided by a definite period give the flow rate. So guys, thank you for watching. We'll meet with our next chapter, that is size reduction. Stay safe and healthy. Bye bye.